Okay, so in this video we're going to go over graphing lines. All right, and just a reminder here, so far we've put lines in terms of our function notation, where we had something that looked like this, and we called that the slope-intercept form, right? Also known as, or sometimes written, where you interchanging y and f of x, like this. And sometimes lines are given in standard form, right, which is not in function notation, but looks something like this, right? Where again, there's always MB, capital A, B, C. Those are all just some real numbers. All right, so there is a variety of ways that we can approach this problem of graphing lines, right? We are dealing with a line, so the minimum that we need is 2 points on the line, right? We plot them, we connect them with our writing utensil, and that is the line that represents all the points that this function is representing. Okay, so one way to approach this is simply by, especially if it's given here in this form, f of x equals mx plus b, it might be easier just to plot some points, right? So for example, let's say let's try that again. Let's say my function was f of x is equal to 3x minus 2. All right, and let's say that I want to plot some points. Now, which points do I plot? It really doesn't matter. Right, so I'm going to choose an input and calculate the output. I'm going to make myself a little table here. X input, output f of x. All right, and again, right, which ones you want to choose does not matter. I'll choose something easy to calculate. Let's the first one be, let the input be 0. So f of 0. All right, easy enough. 3 times 0 is 0. We're left with f of 0 is equal to negative 2. So our output is negative 2. All right, and then let's choose another. How about f of 1? All right. F of 1, I get 3 times 1 minus 2. 3 minus 2 is 1. All right, so f of 1 is 1. All right, easy enough, right? So I think I have enough information to plot this line. Right, so what I'm going to do here, I'm going to draw my coordinate axis. So what I want to see from your work, from your coordinate axis, is that you label these axes, right? A lot of times I get this, and I'll just draw a line. Right, so let's get in the habit of, right, labeling what each one of these axes represent. And also label these tick marks here. Okay. All right. So I have two ordered pairs. Right. So I'll go to the first one is 0, negative 2. So 0 in the x direction, and then negative 2 in the y direction. So that's my first point. My second point is 1, 1. So 1 in the x direction, 1 in the y direction. All right. And that is my second point. Take my straight edge, line these up, and there we go. Okay. All right. And now we have our equation of a line. Okay, so that's one way to approach this. Right now, another way to approach this is by, well, especially if it's given in this form, right, the slope-intercept form. So let's take another approach to a problem like this, where I'm not going to do any calculations. Right? I'm going to just right away. Yeah, I think I got enough room down here. Let's use this room down here. So let's say that my function negative 1/2 x minus, let's say plus 3. All right. Okay. All right, so I'll start in this case here. It's in slope-intercept form, so actually I don't need to calculate anything, right? Again, once I know what those pieces of information is telling me, right? This is called slope-intercept, right? I know the slope. The slope is -1/2. And I know the, in this case, y-intercept, right? When we say slope-intercept, we are implying that it is the y-intercept. So in this case, the y-intercept. And remember, the y-intercept is a point. It's not a number, right? It doesn't make sense to say 3. The y-intercept is 0, 3. Okay? All right, so actually all I need is both of these pieces of information. All right, so here, let me see here. 1, 2, 3. 1, 2, 3, 4, 5. Okay. Okay. So I have 1 point, 0, 3. Right? Now my second point, the way I'm going to find that is I'm going to use the slope. Right? The slope is sometimes called rise over run. All right. So rise tells me how many to go in the y direction. The run in the x direction tells me how many units to go in the x direction. Now I want you to be careful here. All right. This I can also interpret as 1 over -2. So when we're thinking which direction do I choose to go in the negative direction, it's important to realize that you can go in the x direction negative or in the y direction, but only in one of those directions. If you actually do negative in both directions, you actually now have a positive slope, right? And that's not what we have. We have a negative slope. Okay, so just keep that in mind, right? If you're going to use the negative in the numerator, right? So the rise now becomes a decrease, right? And then the run will go to the left instead of the right if you use the -2 version of this here. Okay, so just keep that in mind, right? Now, to get my next point, I'll use the rise. Again, negative means go down 1, and then run 2. 1, 2. And that would be my second point. All right, and then you'll also notice here if you chose this meaning of it, so you would rise 1 and you would go over 1, 2, and you would see you would find yourself back on that line. All right, so as long as you just go negative in one of the directions, being the rise or the run. Okay, and then you might be asking, all right, well, is this actually on the graph? All right, and you can confirm this, right? This point is 2, 2. So if I plug in f of 2, I get -1/2 times 2 plus 3. We get -1 plus 3, which equals 2. So it is, in fact, on the graph. All right? So now there's a way to graph this line without having to calculate any points, as long as it's in slope-intercept form. Okay? Now, keep in mind here, if your slope is a whole number, you could still use this approach, right? When it's a fraction, we could say, all right, rise over run. But if your slope was, for example, 2, right, remember, 2 can also be written as 2 over 1. And now you have your rise over run. Okay, so that's another way to interpret the slope when it's a whole number, when you want to figure out how much do I rise, how much do I run. Okay, now a third way to graph this is using the xy intercepts. Now this is useful when you have a function that is given to us in our standard form. So again, standard form is, all right, now you could solve for y, right, and do the slope intercept form. That's totally a valid way to do these. But let's say you don't want to do that. Right? Or you don't have to. You can actually save yourself some time from solving for y. Right? You can use the x and y intercepts. Right? The y-intercept we've already established was it looks something like this, right? 0b, right? Where the x value is 0, and then you find the y value. The x-intercept has this form, where the y is 0, and then a is some value, right? Some real number. Okay, now let's say we want to use this fact. So these are two ordered pairs, right? Remember in the beginning I said, what do we need to graph a line? Well, we need two ordered pairs, right? 2 points on the line. Okay, so let's say we wanted to graph Okay, let's say I wanted to graph this equation here. Now, like I said, you could solve for y and do the slope-intercept form there, or we can simply find the x and y intercepts, right? Here, that just means, they're easy values to calculate, right? So the y-intercept, the x is equal to 0, and when that happens, right, when x is 0, we're left with negative 2y equals to 6, or y is equal to negative 3, right, by dividing both sides by negative 2. All right, so now we found our y-intercept, 0, negative 3. Our x-intercept, that happens when y is 0. Okay, when y is 0, we get 3x equals to 6, divide both sides by 3, and we get x is equal to 2. So we get 2, 0, right? Easy enough, right? Didn't have to solve for y. Was able to calculate these values right away. Now let's plot this line. All right, and then here, all right, again, x, y, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. All right, so plotting these, we get 0, negative 3. That's our y-intercept. And then our x-intercept is 2, 0. All right. Okay, and then we just connect these here. And now we have the equation of our line. Right, so here's another way to graph this, right? So there's different approaches. Again, really, I would let whatever the equation looks like guide you, right? If you're given slope-intercept form, right, I would just plot the y-intercept and then use the slope to get the second point. I think that's the most straightforward approach. All right, if you're given a standard form, right, then the intercepts might be the best part, the best way to do this. Okay, thank you.